this video we will be learning about Leibniz rule. It's important rule, and it tells about the differentiation under integral sign. In short, also we can write it as DUIS. That is nothing but differentiation under integration sign. तो ये rule क्या कहता है कि if we have the function which is having a parameter, so let's say like f is x alpha, like which is having a parameter over here. Now how to decide parameter, that we will discuss when we will solve the question, how to find in the given function what is the parameter and what is not parameter. Okay, that will discuss when we will actually solve the questions. But whenever its function is having some parameter in that case, what the rule says is, if we with respect to that parameter, if we differentiate this function with some limit, constant limits with some constraint, we call them as a constraint, then this is equal to, if we can shift this differentiation inside the integration sign. Means that's a reason we are calling it differentiation under integration sign, because if you look at the right hand side, this differentiation we have shifted inside the integration sign. Here it became partial differentiation. So that's what it says. When we shift this differentiation inside the integration, it becomes like a partial differentiation, so which is equivalent, both the values will be equivalent. So right and left hand side we differentiated, we find the differentiation of integration, and on the right hand side we are finding integration of a differentiation. That's the both sides, that's a difference we need to understand it here. So and the other thing is, when we are shifting this differentiation inside the under integration, then it is becoming partial differentiation as well. So here we are finding a differentiation under integration sign. That's what the Leibniz rule says. This will be more clear when we will go with the question. Here I try to brief steps which were involved in this. So the steps are like, first of all, we have to identify parameters in the given question, in the given function. What is parameter we have to understand, because in the next step we will be differentiating the given function with respect to parameters. So that's an important step. So after differentiation, then we will be applying Leibniz rules, like shifting differentiation under the integration sign, that we will be doing. And further we will be simplifying it by using the differentiating with respect to parameter. So let's start with the question, so which will give this rule will be very clear by solving the question. So here the function is given in terms of x and alpha. So this is the function which we have to evaluate. Alpha is greater than 0, it's a positive value. So constraints are 0 to 1, like limits which we say that. So the constraint has been given 0 and 1. So x raised to alpha minus 1 upon log x. So first of all, let's start with the given function. So we will write it, given function as it is. Now the first step, which we have seen in the previous slide also, we have to identify what is the parameter. So parameter कैसे identify करना है कि अगर if I integrate this given function, like if you have seen the questions, we never seen that log x in the denominator. So in that type of questions, we normally we use this Leibniz rule. Now here alpha is a parameter. Why? Because see, if in case if you integrate this given function, then with respect to x, if we would have integrated it, so we would have get something in the terms of x, and whatever these limits, this constraint has been given, those are for x. So we would have put some values for x, like for example, if we integrate x, so if you, after integrating, whatever values you will be getting, like x square by 2, those values we put it for x, because those are for x values, right? So same thing here, if I will integrate this with respect to x, So I will get something in terms of x, and then for that x value I will be keeping upper limit and lower limit. So like here I can keep upper limit and lower limit as well. So same thing is for, we could have replaced x value with the upper limit, lower limit, and after putting that, whatever is still left, that is nothing but the parameter, because we would have not able to replace alpha with anything. So that leftover, that is nothing but the our parameter, means we cannot write any value for that. That's how we can identify what is the parameter in the given function. So here you see that alpha is the parameter. Now again I have considered this given equation, given function as a function of alpha, which is parameter here, and I called it as the equation 1. Now our next step would be, we have to differentiate this with respect to alpha, with respect to parameter. Here in our case alpha is our parameter. So now we will get it d by d alpha with we just differentiated left hand side, which is f of alpha with respect to alpha. So d by d alpha of this function, and right hand side also I have did the same thing over here. With respect to alpha and with respect to alpha we have differentiated it here. So rest of the thing I have kept it as it is. So next step, what we will do it, we will apply the Leibniz rule. And what Leibniz rule says that when we are differentiating a function, here we can, what we can do it, we can shift this differentiation, we can shift this inside the integration sign. So we have shifted this inside the integration side, so which is del by del x of the same function which is given in the question that we have did it here. This is the given function, right? And we have shifted that inside the integration side. We have to this one. So now we will try to simplify this here. So after differentiation of f of alpha, that in other words how we can write it is as like f dash of alpha, like something like y. If we differentiate it, then we write it as a y dash. The same way here f of alpha we have differentiated, so we just wrote it as a f dash of alpha. And here we have used this rule. This is quite important rule. Since we are here, you have to remember that we have to we are differentiating with respect to alpha here. So that normally what we do it, we apply this rule when it is x raised to n. So we write it is here. Normally when we differentiate like a d by dx of x raised to n, this is what something which is normal here, like n is a constant, then we shift that n and we write it like n into x s raised to n minus 1. So see here we are differentiating with respect to x, but here in this case we are differentiating with respect to alpha. So that we have to keep it in mind. So that's why we can look at this rule. Differentiate, we are differentiating it with respect to x, but x is variable is this one is power over here. So in that case what we write is n raised to x into log n. Same thing I have done over here, x raised to alpha and log x over here. And this will become like a 0. Differentiation, it will become 0 and log x will be as it is. Now next thing will be this log x simply will get cancelled, and I will get just in terms of like x raised to alpha. Now if I will integrate it with respect to x, so it will give x raised to n plus 1 upon x alpha plus 1, and this upper limit lower limit will be like a constraint will be 0 and 1. So simply I have to put those constraint as upper limit minus lower limit. So I will be getting this one. This constant will be outside 1 upon alpha plus 1, and I just put upper limit which is 1 and lower limit as a 0. So this is nothing but the value of this one, differentiation of f of alpha, or we can say that f dash of alpha also. So this is what I got the value for it, because if you simplify this, this will just, we will get it 1. So we will get finally this one, 1 upon alpha plus 1. We will call it as equation 2 here. We got the equation 2, we called it as equation 2. Now we have to keep it in mind that we need to find the value of f of alpha, and we got this is like a differentiation, so which is f dash of alpha. So now we know that integration and differentiation is exactly opposite to each other. So if you want to find the value of f of alpha, definitely we have to get rid from this one. So that's why we are integrating it, this one, both side. Why? Because this is f dash of alpha, we got it, and we want to get f of alpha. So we have to apply the integration, so that derivative and integration will get cancelled, and we will get f of alpha's value. That's the reason we are here integrating this equation 2 with respect to alpha. So just I put this both the side integration, and with respect to alpha we will be doing it. Now here I applied the formula, like here f dash of x, f of x upon f dash of x with respect to dx जब भी हम करते हैं ना, तो अगर इस तरह की सिचुएशन है, दिस विल बी हियर, डिनोमिनेटर में f of x होगा और उसका डेरिवेटिव अगर न्यूमरेटर में है, और दिस टाइप ऑफ सिचुएशन इज देयर, एंड इफ़ यू आर इंटीग्रेटिंग दैट, in that case उसका इंटीग्रेशन हो जाता है log of f of x plus c. So this is the thing, log of f of x plus c. So same rule, we will be same integration formula, it's a formula we will be applying over here, because if you see here it's at the denominator it's alpha plus 1. If you differentiate that, you will get 1, so which is there in the numerator. So this is exactly same like here, f dash of x upon f of x, and that's the inside integration. So we can apply this formula, so it will be log of f of x. In our case f of x is something, this one, alpha plus 1, which will be, we will be writing in the modulus sign, and we will call it as and c is obviously the integration constant, because we did integration, so that will be there. We will call it as equation 3 here. Now we have the value which is alpha, f of alpha value, we got it, that is along with the c value. So our next thing will be, we have to find the value of c, so that we can substitute it, and we can find the proper value of that f of alpha. So now in order to get the value of c, what we can do it, we will keep the substitution alpha is equal to 0 in equation 3, which we just got it here for f of alpha. If you substitute alpha's value 0 here, so everywhere, even on the left hand side also, so this will be f of 0, which will be equal to 0. So that's how we will get it. But here this is also, we haven't got the c का पूरा value, हमने अभी भी नहीं निकाला है, सिर्फ उसका c is equal to f of 0. Means it's in terms of f of function, it's not actual constant value or anything we haven't received, वो function के form में निकाला है. So that's the reason again we have to find this value. What is this value? f of 0 की value हमें निकालनी होगी, तभी हमें c की exact value पता चलने वाली. So हम f of 0 कैसे निकालेंगे? So obviously in the function we have to keep that value at 0. So that's the reason we are going to find f of 0. So f of 0 मतलब wherever it is alpha, we have to keep it 0. So मैंने यहाँ पे जहाँ equation 1 में wherever I get alpha, I have put its value as 0. So after that I got the value of f of 0. So now f of 0, by doing that I got it like a 0. So this is nothing but a value of c, क्योंकि हमने पहले देखा था c की value, c was equal to f of 0, and since we don't know f of 0, so we did substitution alpha is equal to 0 in equation 1, so that we got the value 0, और ये value c की भी value होने वाली है. So now this we got the value of c here. Now this we will put this value in equation 4, so that we will get f of alpha value. So this is how now we put this value in equation 3. सो जो हमने यहाँ पे लिखा था एफ ऑफ अल्फ़ा की वैल्यू, सी की वैल्यू यहाँ पे अननोन थी, अब हमने वो निकाली है बाय कीपिंग अल्फ़ा इज इक्वल टू 0. Now after getting that, again we will be using third equation and we are going to substitute in that. So now this is the reason, see, instead of c I have put it here 0. So whatever we are getting, that is nothing but the value of f of alpha. So just simple steps are there which we have to keep it in mind, but the integration rules you have to know it very clearly. अगर आपके इंटीग्रेशंस के रूल, अगर आप इंटीग्रेशन के कुछ डाउट्स है या तो वो क्लियर नहीं है कंसेप्ट, so before you go with Leibniz rule, please make sure that those get clear. You understand all integration, then it will be easy for you to understand this Leibniz rule. Otherwise थोड़ी सी दिक्कत आने वाली है. तो सबसे पहले आप इंटीग्रेशन को पूरा अच्छी तरह से रिवाइज कर लीजिए, सारे रूल्स जो भी हम किस तरह से अप्लाई करते हैं, अपर लिमिट लोअर लिमिट कैसे करते हैं, कैसे सब्स्टिट्यूट करते हैं वैल्यूज़, दैट शुड बी क्लियर. अगर वो अच्छी तरह से आपका क्लियर है कंसेप्ट इंटीग्रेशन का, तो उसके बाद ये काफ़ी आसान है करना. अगर नहीं है तो आई विल एडवाइज इट, यू शुड गो हेड एंड वो इंटीग्रेशन एक बार अच्छी तरह से कर लीजिए. आफ्टर दैट यू गो विद दिस रूल, सो इट विल बी easy for you. So this is again in short what we do it. First thing is we find the parameters in the given function, then we differentiate the given thing, a given function with respect to parameter, then we apply the Leibniz rule. Then in Leibniz rule we shift that differentiation को हम integration के sign के, what we do is we do differentiation under integration sign. That is the important thing which you have to understand it. After that you have to apply certain rules and for simplification some formulas, so that you will get value of f of alpha. In our case we did integrate it again we to find the value of f of alpha. बाद में उस c की कांस्टेंट की वैल्यू हमने निकाली थी बाय सब्स्टिट्यूटिंग अल्फा इज इक्वल टू 0, और वो वैल्यू मिलने के बाद देन वी केप्ट इट इन द प्रॉपर इक्वेशन ऑफ एफ ऑफ अल्फा एंड वी गॉट द वैल्यू. इंटीग्रेशन का अगर कंसेप्ट क्लियर है, सो आई थिंक आई होप यू वुड हैव अंडरस्टूड दिस वेरी क्लियरली. थैंक यू.